And welcome back to the Turdferg Viewing Network. Alright, today's problem is part 2 in our series on series and parallel resistors. So we've went through basic series. Matter of fact, last video we did, we had one circuit that looked like this, 3 resistors in the series. And then we had this problem where we had 3 resistors that were in parallel. So now this next problem we can take a look at, and here's the picture they gave, and I like to blow it up a little, and they told us that resistor R down here was actually a 20 ohm resistor. I like to write it a little bit bigger where I can see the picture better, and I'm not actually going to look at this stuff. I can figure out everything they're going to ask, because these problems always ask basically the same things. And so the first thing is they're going to ask, what is the REQ or R total for this entire problem? And where they try and mess you up is this. The first thing you should be going is this series or is this parallel? And you've got to notice something in this problem. You've got to notice, you've actually got a 4. Why am I pointing with my finger? You can't see that. There's a 4 and there's a 9. And you see the 7 and 20. Well, here's the thing. The 7 and 20 are in a series with 4 and 9. But the thing is, the 7 and the 20 are parallel to each other. Remember, parallel means the current can split. And that's what makes these two in parallel with each other. Well, that's no problem. To reduce these, all I've got to do is 1 over 7 plus 1 over 20 and take a reciprocal. Don't forget that reciprocal in there. Now I'm going to have to close this off and go find my calculator. There it is. So I've got 2 resistors, a 1 over 7, and I need to add into that this 1 over 20. And that comes out reciprocal to 5.2 basically. So this is a 5.2. So here is all we've done, and if you really need help with this a lot, go back to my physical science videos because they're great. What we've essentially got is this. It means we've got a 4, and then you could replace that 7 and that 20 with a 5.2 ohm. So all we're going to do is treat this like it's a series. So in other words, we found that these 2 resistors combine to make a resistance of 5.2. And now if you want to know the R for the entire circuit, all you have to do is add up this series. 5.2 and 9. So if you've ever got resistors like this that are in parallel, you reduce them, you find their equivalent resistance, and then you just add your series together. And so in this case, we can go back and add all this up, and we pretty much got 9 and 9.2. So that's going to be 18.2 ohms, and that is our equivalent resistor. And here we'll check our answer. 18.2. Apparently we are doing quite well at our math. Now, I'm not even reading their questions. I'm going to go ahead and do something. Every problem I work, I want to come over to where this battery is, or this EMF that's over here, electromotive force. And I want to do something. I know that my resistance is 18.2 for this problem. So I want to come in here, and I want to see if I can somehow figure out what my I is. I want to know the current leaving this battery. So I'll go V equals IR. By the way, every problem from here on out I'm going to answer with that equation. And this would be 24 equals I times 18.2. So I'm going to have a pretty low current here. 24 divided by 18.2. And it looks like a 1.32. I'm going to have about 1.32 amps of electricity. Now this is what is leaving the battery, or leaving my potential, is 1.32 amps. So let's follow that current. What's going to happen to it? Well, that means going through this resistor is 1.32 amps. And then notice something. When you get to this junction, and that's what you call that, this current splits. Now, the thing is, I don't know how much current here. We'll call that I1. We'll call this one I2. I don't know what those currents are, but I know this. Whatever these two currents are, if you combine the current through the 7 and the current through the 20, I know, though, that the current through here has got to be equal to 1.32 amps, because that's how many amps left the battery over here. So we keep following the electricity. So whatever these two currents are, they do total 1.32. And so these currents will come back to this point and recombine, which means going over here is a 1.32 amp current. Now, I haven't read the problem yet, but I've got this strong feeling it's going to ask us to find that I1 and that I2. So how do you find that I1, that I2? Well, that's pretty easy. You see, when you have this current going through, every single part of this circuit is going to use up part of that potential. Every single piece of this circuit will use up some of this potential. Matter of fact, let's do something real quick. What would be the potential over this part? Well, just for curiosity, V is I times R, so that would be 1.32 times 4, which is going to be roughly like 5.2 volts, but here we'll do it in our calculator and get it exactly. 1.32 times 4, 5.028. Man, I got so close. So this would have 5.28 volts of potential on this. So in other words, that's how much of our battery is essentially getting used up to push the electrons through there. And now let's do the same thing for this. V equals, now here's what I'm looking. I want to know the potential being used over this. So I'll look at the amps that are going through it, 1.32 amps. And I'll look at the resistance, not of the 7, not of the 20, but I'll look at the resistance of this entire piece of my puzzle, and that's 5.2. And now I can come back, grab my Casio, 1.32. Oh, come on. You're not going to let me go back? Crazy thing. Times 5.2. And I got 6.86 volts being used up over this little piece. So I've got 6.86 volts of potential being lost over this piece. And here's the thing. I could figure out this last potential, and here's what will be cool. All my potential should add back up to 24 volts over here. But I'm going to stop right here, because here's the thing. That means if the potential of this section is 6.86, that means that there's 6.86 volts on that resistor and 6.86 volts on this resistor. Because voltages stay the same. If you forgot that, let's go back to like my very first little talk. And if you remember, volts, potential stays the same in a parallel. Now this one's just tried to make it a little bit harder, but we're still in that same area. So we'll come back and take a look at this. That means there's 6.86 volts on each one of these. So here's the thing. If I want to find the current for the top, all I need is that V and that R. So I can come down here. V is equal to I to R. And my V was, I've already forgot, 6.86. 6.86 equals I2 times, I want to find how much current is through the 7, so I'm going to use 7. This is going to be like 0.97 probably, or something pretty dang close to it. Let's see, 6.86 divided by 7.98. Now this is going to be neat. We just figured out that there are 0.98 amps going through the top. So how many amps, if we've got 0.98 amps going through the top, 1.32 amps went into this, how many amps are left to go through the bottom? Well, 98 from 1.32 would be 0.34 amps are going through the bottom of this. And again, if you need to watch a lot more of these and really broken down, go back to the physical science playlist. I do spend a lot more time there going over this little concept there. But let's check our answers. This has got I through the 4 ohm resistor. They've got 1.87, and wow, I got 1.32. So apparently they disagree with me. And I picked a bad time to get this problem wrong if that's the case. Poppycock. I don't know what they're thinking. Actually, I do know what they're thinking. I used a 24 volt battery, and apparently the problem said use a 34 volt battery. Well, I don't care. This is the Turdferg Network. Watch this. 24 volt. Therefore, I declare these answers to be wrong and my answers to be right. So the answer should be 1.32. Let's see. Through the 7 is 0.98. Through the 20 is 0.34. And then through the 9 is a 1.32. Who you going to believe anyway? WebAssign or Turdferg? Dance with the one that brought you. That's what I always say. All right. Well, thank you. Take care. Adios. C'est la vie. Later.